Hello viewers, I'm excited to be here today again to share my insights on Selenium test scripts which I've worked recently. It was an automating tool. I built a basic framework. As we all know, a framework is an amalgam of support program, different classes, compiler, library, and different tools. So I tried to add all the things which are required for this framework. Basically, in this framework, what I did is there is a pagination part in the tool which I am automating. So that pagination part I have run till the nth page and then grab all the details into the console, and from that console I have pulled all the details into the Excel by using Apache POI. For this, on a basic level, I have built a Maven project. Maven is a built automation tool that helps to manage dependencies, add different plugins, build processes, and to show it in the IGA clearly, here you can able to see the structure, right? This kind of structure will be formed whenever we create a Maven project. SRC main Java, SRC test Java, the project will be in this structure whenever you create a project in Maven. So here in the code, you can able to see the testNG annotations. I have used some basic annotations, which is a test. So on a high level note, I used a testNG framework upon Java and followed page object model as a design pattern. And also I have included Apache POI for reading and writing the data through the Excels. So coming back to the testNG again, here I have used testNG. You can see at test annotations here. So why we actually need it? To know this, we need to know the drawbacks of writing a plain Selenium test scripts in Java. So the scripts written in Selenium are not user-friendly, which makes it hard to modify the code. Though it supports multiple programming language, it requires a high-level proficiency to deal with it effectively. So Selenium requires any third-party frameworks in order to complete automate. Like if you need any reporting or any other filtering or prioritization tasks, or need to perform the splitting of the test cases, then you will require some additional third-party tools in order to perform. So depends upon all these drawbacks, they come up with a tool called testNG. So this is why we incorporate testNG in our test script, and also because of the fact that it provides many user-friendly functionalities. It also generates the logs, HTML reports, grouping, annotation, prioritization, and dynamic test reporting. And one more tip is, if you're a beginner and you're not completely aware of all the annotations that used in the testNG, then you can start writing the entire test script, test suite, the entire framework in the Java itself, and then you can able to convert it later on into the testNG, or you can even convert it later on to the Maven projects as well. And in detail, when you're moving through the entire hierarchy here, you can able to see the pom.xml here. Yes, similar to the Maven project, you can write the scripts in a single main class without using any pom.xml. But including pom page object model, we can achieve easy maintenance, reusability. So here we have a different variables or the data members. You can reuse them anytime with the help of this pom.xml. As we are adding all the dependencies here, we can make use of all the details which we are actually using. And also pom is the file that we add all the dependencies. So whatever the project requires, all the dependencies will be added in the pom.xml. So under this dependencies tags, you can able to see all the dependencies which should be added as a part of the framework which we are actually using. Here we can see Selenium HQ and testNG you have, and for now JUnit is not there, as we are yeah, it's there, but it is not required as we already working on a testNG. So JUnit is a little bolder one. And also here we have Apache POI for doing all the Excel operations, performing operations, read data, write data through the Excel. And here we have 3 libraries for Apache POI, and that's it. We have enclosed the dependency tag. And also here underneath the dependencies, here we have reporting tags. Here we have surefire, right? These are for the enhanced reporting functionalities. You can have a dynamic reporting by using these surefire and the failsafe Maven plugins. Now moving on to the actual code here. As it's a common practice, I have used all the members as a private members. Here we are actually encapsulating the internal state of the main class. So by giving the scope, preventing the scope with a limited access for unintended modifications in future. So as every other class, here are owned and managed by the test class, and all the members are the private here. So and here in beneath the data members, you can able to see the before class annotation. So it is a part of testNG. So at before class annotation is useful for the tasks that need to be performed only once the entire test class, such as you can perform initializing or setting up resources or creating common object that will be used across multiple test method. For such actions to be performed, you can include all those operations in the at before class. So in that we are initializing a variable with the test data, which as admin, which we are actually giving the test data. Here in the next line, you can able to see the Chrome options. Chrome options equals to new Chrome option. The option variable is an object of the Chrome options class, and then you can able to see options dot set accept insecure certificates. Here we are passing the parameter as a true. So by setting this option to true, you are telling the Chrome to proceed even if it encounters any insecure certificates. Generally, in some of the private address or the private applications, when you open, you can able to see the certification part, which you need to give again to proceed for the actual website. So to eradicate that, you are giving here set accept insecure certifications part. So the next line, it's the actual line where web driver equals to new web driver, new Chrome driver. Here we are, as we all know, here we are instantiating the Chrome driver class with WebDriver interface. We are just customizing with the options here. Like we are not seeing the actual things here, but exact syntax here, but we are just customizing here with the options. We are passing options as an argument to the Chrome driver constructor, and WebDriver, which is already declared in the private variable, so we are directly giving the private here. And in the next line, you can able to see the implicit wait with some set of timestamp. It set the maximum time that the WebDriver will wait for an element to found when trying to locate it. And then we have this workbook equals to new XSSF workbook. Here, what we are doing is, here is the Excel workbook part. After retrieving all the data from the pagination part, now we are reading all the console output to the Excel sheet, right? For that, we are creating a workbook. So create a new Excel workbook here, and using XSSF workbook class, which is also a part of Apache POI library. And then here we are giving console output writer equals to new console output writer. It actually initializes an instance of the console output writer class. So what it is doing is it calls the capture console output method of console output writer, which actually redirects the standard output which should be there in console. So this standard output, it is taking and reading it. So actually in a summary, what we are actually doing in the add before class method is we are setting up a WebDriver for Chrome driver and initializes an workbook for the like Excel handling and prepares a header row for recording whatever the details we retrieve. And additionally, it also initializes the console output writer. Since we are grabbing all the details of the console output, we are taking all the details from the console output writer. And then we have the first attest class, first attest annotation here. Attest represents actual test method. You can even call it as a test case. So this is one of the test case, which is a login test case. So here, when we redirect to the login page, so from that main class, we are calling here the WebDriver. Here it is an instance variable which is passed as a login page constructor. So here we are passing a WebDriver as a constructor parameter with this keyword. So when an object of the login page class is created, this constructor will be automatically called. So we already know that this keyword refers to the current object in a constructor. So whenever we highlight this, you can able to see this driver is highlighting. Whenever we highlight this, we can see these drivers are highlighting. So these all are like interconnected. You can able to see by highlighting each one of them. And then in the next line, you can able to see this page factory initializing elements. In the parameters, you can see the driver, this. So this is also a part of a page object model design pattern. So in the login page class, using the initializing element method from the page factory class, we are using this at find by annotation. So unlike the old traditional way of writing the locators, here we are doing a different way of writing the locator strategies, which is a at find by, which improves more readability of the application. So here, this is the actual syntax of the our normal traditional way of writing the locators. Here we just give the at find by annotation, and whatever the XPath we write, we give it as a parameter, and just we call the web element with certain name. And then in order to initialize the elements with the driver, here we are giving this line. That is the purpose of writing that line in the constructor itself. And here the rest of the code, you can able to see it's like a normal code. Like here you can able to see we have written the send keys annotation and everything we have written in the find by annotation, and everything is simple over here, nothing much complex. As we actually move towards our actual code, similarly we have this page scroll class. So whenever we want to scroll the page, you can either do it with the actions class. So with the help of action class, we actually perform dynamic actions, right? So here we are performing the dynamic actions with the action class. This is the and passing driver as a parameter for its constructor. And here we also can see we have used a super keyword for getting the parent class driver here into this class. So we give by. Generally we give driver dot find element by, right? Here we have given by, which represents the half of the path is already written in some other classes, and we are pulling that directly here in this class without writing entire XPath or entire locator. We are just grabbing the half of the path, grabbing from half of the path, as it's consistent in all the pages. And you have another class as well, which is like it's normal usual class. You have to set some frequency in order to do the checks over there. So here we are just setting up a frequency, and you already know here list with the, whenever you want to locate a single element, we do driver.find element. Whenever we want to do some bulk of like list of elements, we will generally use a list of driver elements, right? So this is the one as we have executed all like run the loop till the size. So whatever you want to read, whenever you want to read the list, just write the list to the entire web elements, and then just run the loop till the size of the entire list, and then grab the details, whatever details you want, just grab the details, or if you need any condition for that, just apply the condition and break it. That's the generic way of writing or grabbing all the details from the list. So coming to the actual pagination test, here you can able to see that we actually first we scroll down a bit. Dynamic actions again, to perform dynamic actions like this, we generally use action class, or whenever we use action class, it takes more time to load because we need to incorporate many steps to perform with action class. So easiest way of writing window scroll down is with the JavaScript executor. So we include a JavaScript snippet over here, which is a scroll by method. Here we can able to see that we have applied do while loop. There's a big reason behind do while loop. So whenever you see a pagination, right? So first page should be read first, and then only it should move to the next page. So after grabbing all the details of the first page only, it will move to the next page, and the loop will start, and the entire recurring will be happen, right? So the first page should be written. The app conditioning would be a do while loop. For example, let me show you first how the pagination actually looks like in the real time. Here best example would be your online shopping. Whenever you go to your e-commerce websites, here you can able to see like show more options or something. So whenever we do this, there will be a lot of pages which will be generated automatically. You need to pass all the pages and do that, like grab all the items and do that. Another best example would be like some applications which we similar to the SharePoint applications, like we have several pages here, you need to pass with the entire pages. Another best example would be this. We all know, we all are very much aware of this, Google. So whenever we search something in the Google, here we will get some n number of pages. So firstly you need to read all the details from the page and then move to the next, which will take you to the next, to the second page, and then again read all the details and move to the next page. So that is the purpose we have written do while loop and not the while loop. So this is the real-time example of our pagination. Let's move to the code again. So here, as you can see, I have given next button is not disabled. So as soon as when I move to the next page, and it will generate the new page. So when I am trying to continue till the nth page, at the time of getting the nth page, the next button will be disabled. So I need to run the loop till that page, like where the next button will be disabled, right? So here, whenever you see this, here you can see like after reaching to the 9th page, the next button will be disabled, right? So that is what here we are writing. And you can have here with the tool, we have utilized a loop. We have listed out all the elements from the first pages, and then we have certain set of titles over there. The current pages which I'm running, that has a certain set of titles. So I'm running the entire title size for loop, and then grabbing all the details here. After grabbing, I'm like filtering out the data. So I'm taking it in the Java streams and lining it or splitting it or reading the length and doing all the map part. And then you can have the thread.sleep to pause the execution. Whenever some pages are not loading properly, you can have this thread.sleep to pause the execution for a bit. And here we are writing the format of outputting the data. And again, I am giving some condition for the assertion purposes. And here you can see element to be clickable. These are keyboard elements or mouse elements will be there. No, it comes under that. So again, here we are writing the exception handling for proper loading of page and proper scrolling down of page, whether the element hit in the current DOM or not. If sometimes what happens is we will get a lot of exceptions, majorly stack overflow exception whenever the element is not loaded properly in the current DOM which we are focusing. So in such cases, you must need to have an exception handling. Otherwise, it will always fail. So this is the part of pagination majorly, and we have another one which is a console output writer. Again, in the console output writer, we have all the private members, which is a console output. We are reading the console output and having a workbook and the sheet, row number, everything. We have different methods like console output and capture console output. Console output here, it's like in the constructor, we are all giving all the details which we actually require, and we are creating a header over here. In what format we wanted to grab the console output into the Excel. So this is the format we are expecting, like first serial number, then title, then status and all, and then we are capturing entire details into the capture console output. Here, output stream. This is the class required to perform input-output operations in Java. And for performing such operation, we generally use a java.io package, right? So similar way we have used this. This basically provide a mechanism to read data from the source and write it to the destination. And then we have this string builder. We named it as a buffer. It's created to accumulate the characters from the console output. So buffering and the building part are like related to the accumulation of the characters, right? We are accumulating the character from the console output. So as we already know, at override, this annotation actually we need to write. So this annotation informs the compiler that we are overriding the superclass. It will be easy for the compiler to guess that we are overriding something from the superclass. So here we are seeing something different, right? System.out. So system.out is something that is different from what we have used till now, like system.out.println or system.out.print. So difference is system.out is a standard output stream and it is by default connected to console. So when you use a system.out.print or println, the output is redirected to the console. But system.out, it is by default connected to directly console. So however, there are certain scenarios where you might want to capture or redirect the output that would normally go to the console. So such details, this is where the system.setOut operation comes into picture. So whenever we want to capture or redirect the output that would normally go to the console, we will generally use this setout. So the last method, I won't go deep dive into this. I'm just giving you a high level on this. This method actually writes the captured console output to the Excel file, the final operation which we are actually doing. So the final operation which we are actually doing, this method actually write all the captured console output to the Excel. Each line in the console output correspond to the row in the Excel sheet with the columns and the serial number and the console output. Any exceptions during this will be handled in the exception block here. And this method uses like file output stream to so whenever the try block is exited, this is convenient way to handle the resources to be closed after used. So and then we have this closing operations after closing Excel. Yeah, here if there is any error, the entire thing will be printed over the print stack trace method over here. It is used to print all the details which are failing, and then after the entire details has printed into the Excel, we have this closing operations and a clear operation for restoring and closing the workbook for fine. It's a fine and convenient way of closing all the things which we have used. After everything is being used, we need to be clear everything. As a common practice, we should ensure that we will write the console clear, restore or the close workbook functionalities properly. And also you can able to check out all the test outputs in the emailable report here, and also you can have this past reports here, index.html, which we generally use. And I will come up with a new session with all the testNG, separate testNG session, so we can able to understand more detailed into the testNG entire annotations and all. So today we have just given a basic understanding of the a basic framework by giving a logic on the pagination part and including Apache POI as a crisp tool to navigate all the console output into the Excel output. So today that's it. Hope everything is clear enough. If anything I'm missing or anything you want to give suggestions, please comment down below. Thanks for watching and happy learning.